Alright, welcome back everyone to another video, and this one I've finally opened up my review kit from Xilinx for the Kira SOM, and we'll take a look at that and see how all of that is. So of course they sent over, so yes, the Xilinx actually sent over an entire press kit review package. With the actual board, they sent out a bunch of accessories which I'll be going through, and I'll also discuss what's different than what the consumers will get, and we'll talk specs, we'll talk the hardware, but that's sort of what I'll limit this video to, because otherwise the video becomes too long, and that's an issue. So we'll just look at the hardware, we'll take the heatsink off, we'll take the cooling system off, we'll take the SOM off, we'll see what's on the board itself, and then in the next one we'll actually turn it on and do a bunch of work. So the way Xilinx is positioning this kit is as a beginning of a new era where you don't need to actually learn how to use an FPGA or any sort of HDL language to program an FPGA. Instead, you can just use C or use the languages and the platforms you already know, and get started within like an hour of unboxing your board. So we'll talk about the board in a bit. Let's see what Xilinx had sent over. As a part of the press kit, we get this stand, but because I have like a top-down situation at the moment, this stand is not very useful. But to show off this board to someone, the idea is to just place the board here, I think, or something like that, and have it stand up. So yeah, so we'll look into that in a bit of detail in the upcoming videos if I require this, and if I can show off the board with other angles. And this is like an entirely 3D printed stand, so this is though not for this video. They send a preloaded SD card, or what looks, no, probably not a preloaded one, because it's all packaged. So yeah, they do send a micro SD card, because that's how this thing boots. And keep this on the side. Stickers, I'm guessing that's specific to this kit, not the final, not the consumer kit, or not the one they're selling. So I got bunch of stickers which I'm happy about, some basic getting started guide, and we'll see what all this has. Basically just a layout and stuff. Power adapter, that's what this box has, and let's see how much juice it actually requires to run. Right, so this is 12 volt 3 amp, which means I can also use my disk power supply, and get more data out of how much power it's actually consuming given the designs and other things that it runs. So might not be using this power supply and use my just use my bench power supply with the proper jack. But yeah, this is something that you get as part of the actual kit. Moving on, HDMI cable, you get it with the kit. Ethernet cable that looks like a Cat6 shielded or Cat7 shielded, you get that with the kit. And micro USB to USB type A for debug, again you get that with a kit, and this is not specific to the press kit. Right, they did send a freaking Brio webcam, which is kind of amazing. So this is not available for regular buyers, it's just a press kit thing, and regular buyers get a AR1335 camera unit. So I'll just have that on the screen. So this is like the kit that you can buy. So you do get the power supply, the HDMI, the Ethernet cable, the micro SD card, and the USB cable, and this is the camera you get, the AR1335, that goes on the ports, the camera ports here, through I'm guessing through the onboard ISP. And yeah, not the Brio. The one we get is a USB 3 webcam. It's the exact same camera I'm recording this video on. So the one Xilinx sent is actually can be dedicated to this project to show off this particular board. So let's open this up just to show you guys what the camera I am talking about. Again, I'll not spend too much time on this one. So yeah, basically the exact same camera as the one I'm recording this on. That's literally exactly the same. So I'll just keep it in the box for now. This is a SOM. Let's go through what's on there. And we have a handy dandy diagram right here to reference the basic stuff, and then we'll go ahead and see stuff in more detail. So here we have the main SOM, obviously. Pretty beefy cooling system. So I don't know if it requires it because it's just 15 watts, but maybe the concentration of power justifies it. We have quad USB 3, a gigabit Ethernet, HDMI, DisplayPort, 12 volt USB in as we saw with the power supply, one PMOD, so that's a generic IO output stuff, JTAG, so that's GPIO, probably stay attached it to the programmable logic side of things. UART debug, which is very much appreciated to have onboard debug chip. I'm guessing that's the FTDI that's connected to both the JTAG and the debug. I think that's the Raspberry Pi camera port here and the micro SD card slot, and a couple of just one single jumper for Watchdog out, and then you have two IAS connectors. So IAS is a new or upcoming standard that's being pushed by OnSimi for their camera modules, and it's just a connector standard, and I'm guessing one of this is the ISP. So we'll take a look at what's what in detail about the chips. So the first thing I wanted to do is to take off the SOM and show you what's underneath it. So here's the fan connector that just comes off, and so it looks like they have nuts on the back side, which is not ideal if you want to take the SOM off regularly. This is the first time I've seen a mounting like that, where the nuts are on the back side. Usually the threading is in these standoffs. So yeah, just going to take a moment to get these off. Right, so that's the SOM out. Looks like only one side of the SOM is populated in our case, and the other side isn't. It should be 254 pins on the SOM. We look at these specs later because I'm really interested to see what's actually driving the entire business. Um, yeah, so that's the base SOM out, and let's then take a look at the sock itself. So from what I've been told, and what's publicly available, this sock is very specific to this SOM. So Xilinx is not selling this SoC apart from this particular SOM. So if you either buy the SOM or you like don't buy this product. Like there's no, the part to product is the SOM and not the SoC or the FPGA. I guess if the FPGA has a bunch of ARM cores, it ends up becoming an SoC just because it then the FPGA bits become the part of the system, and these screws are actually being very difficult right now. And so what's under the fan? Oh, that's just the fan cover. So fan's not connected to this. That's just the shield. That's the fan, and I think everything underneath is connected by these. So let's try and take these out and see if things come apart. So that's a really nice mechanism. It's all spring loaded, so they're not leaving it to just random, force with like the sticky tape kind of heat sinks where there's no actual tension between the PCB and the heatsink, and it kind of reduces the amount of uh, heat transfer that you can get. So this is nice because they are using screws with spring tension to actually pull the heatsink closer and much more tighter to the PCB, and that way it'll actually cool much better. Let's see if the heatsink now comes apart. There you go. Luckily all the thermal pads were in the correct in like stuck to the heatsink, so I don't have to take care of removing the thermal pads from the PCB. So that's your RAM bank. How much RAM does this one have? 4 gigs. Yeah, 512 megabits into 16, and then 4 of them. So 1 gig per chip. So that's your memory. That's probably PMIC and SPI flash. Storage. Yep. Onboard QSPI flash. This looks like a place for eMMC, so I guess some modules will have eMMC. This one doesn't. However, they've tiered them. So this one's only this one boots only from SD card. So that kind of makes sense. PMIC, memory, place for eMMC, some stuff, Jelly Bean Logic, something or the other, and then QSPI flash. That one. Right, so let's clean this sock and take a closer look how it all looks. I have my isopropyl alcohol here and my paper roll, so that we can remove all the heatsink gunk, which we'll replace. So and the stuff I replace it would probably be much better because it's sort of high performance grade for gaming and overclocking CPUs. Alright, not that high performance, not the blue one, but it's a good Corsair thermal compound. Right, so that's all cleared up, at least from the SoC side, and as you can see, maybe I'll clean it up just a little bit. As you can see, there's no chip identification on there. It literally just says Zinc Ultra Scale, and that's it. So let's try not to bring it to a direct light. So I think this is better. So it just says Zinc Ultra Scale, made in Taiwan, and then a QR code, and that's about it. So there's no SOC model or anything like that. I can tell you because they have it on their website, which exactly the FPGA SOC it is. And see, look at the substrate. That's thick. Look at that. You can see the BGA balls right there. I love this camera, and that's why I was so excited that Xilinx sent another one. But like, look at the BGA right there, and then that's your PCB substrate, which the actual chip sits over. So, to be precise, this is. Let's go on to the SOM page. I'll show it to you. This is the XCK26 SoC. So whatever that is. As per the specs, so quad core Cortex A53. It's very similar to what we have on the Ultra 96. Dual core R5, so that's the real time stuff. Mali 400 MP2 GPU. Basic, basic graphics, nothing much. Um, it has a decent video codec unit, so it can do up to 4K 60 FPS, and then divide that into 1 to 32 streams. So the total bandwidth is 4K 60 FPS, and then you can divide it however you want in up to 32 different streams. Infineon 2.0 trusted platform, on-chip SRAM 2.26 megabytes. So is that the B RAM or is that the actual SRAM? Because 26 mega, okay, it's 26 megabits, but still that's still quite a lot of SRAM. And then 4 gigs of DDR RAM and 16 gigs of eMMC. That's so. This is the full-fledged um, uh, SOM, the K26. This has both the IO pins um, and uh, and the eMMC. So I'm guessing with this kit they haven't broken out all the PCIe stuff because that there's no IO on the baseboard for it. So this kit's supposed to be as is. So the PCIe stuff is broken out on the SOM. So this is more or less spec of the SOM plus the zinc chip. So it has PCI Gen 2 X4, a couple of USB 3s, SATA port. Again, the SATA is not being broken out, and 4 into tri mode gigabit Ethernet. So those haven't been broken out as well. Only a single one has um, been broken out, and then bunch of other stuff. Um, on the so there are onboard transceivers instead. So these I'm guessing this PCI Gen 2 is directly from the SOC, and the PCI stuff that's listed here is from the onboard hard IP transceivers. So these can be switched between all of these modes, including a PCI Gen 3 X4, which should be plenty for a very fast SSD. Um, so here are the number of pinouts. 256,000 logical cells, which is quite a lot. A fair bit of DSP slices for fast math, and power consumption is around 15 watts maximum, 7.5 volts on the normal load. Yeah, so the specs looks interesting and promising. Maybe, hopefully, at some point we see with much higher memory, maybe even external memory, but much higher memory capacity is something that I've been sort of ranting about um, in the ARM world, especially for a while. So it would be nice to see. But since this is not like a desktop PC that people have to use, I'm not that much concerned. Hopefully, they know the amount of RAM that their use cases need, and it's plenty. So yeah, let's get back to the board itself. So we've taken a look at the SOM. Let me quickly close everything out, put the SOM back, and then we'll take a look at rest of the board. Um, so underneath the SOM, there's nothing. There's just one tiny chip, and I'm guessing that's just glue logic of some sort. Alright, so that is set, and let's get a closer look at the chips on this board. Um, what all's on there? Let's zoom in, like really in, and see how it's going. Right, so that's, I'm pretty sure, says FTDI, and that's a UART controller of some sort to give the JTAG control and the USB UART. Um, so for this particular chip, I can't really read the number, or it's kind of, they have their internal numbers and you have to reference them in a particular manner to get them right. But I'm pretty sure because of its position right next to this IAS connector that um, this is the ISP, the on semi AP1302. I could be wrong, but I'm pretty sure that's it. This big chip here, is the Displayport Splitter. Um, so this thing, and I'm guessing it gets, so the FPGA provides a downstream DisplayPort here, and then that splits it to DisplayPort proper. So as you can see here, and I'll move this away in a second. So this is what I'm guessing is the FPGA provides the DisplayPort, and then this splits or multiplexes that between these two ports. So the DisplayPort native, so you can see little transceiver here, or I'm probably guessing resistor array in a package, and then HDMI, and I'm pretty sure then this chip is a DisplayPort to HDMI converter, and then you get your HDMI like that. And this right here is a USB hub. So I'm not sure if we are getting two native USB and then that's being hubbed, or all the four USB 3 ports are on a single USB 3 port, and those are getting those are going through this hub. So this one's by Microchip. It's the USB 5744, and it's compatible with USB 3.1. And so the Ultra SOC, the Zinc um, chip has has Ethernet controller inside, so it just needs a transceiver here, and that's what it's doing. It's a gigabit transceiver, and you can see the data sheet right there. So DP83867 CR is the one that's on there. Apart from that, nothing much. Everything else is glue logic. Let's see at the back. Very sparsely populated. Still few which I'll still say are some you know miscellaneous chips of not much direct impact, just to glue stuff together, bunch of resistor arrays, some level shifters and other things like that. Here's the power supply, the on-board power supply. So this takes in the 12 volts and does whatever it needs to do to different things. So that's the switch mode power supply. Again, you can see there are almost no switch mode components all here. It's all on the underneath the board. So that's it, a very simple board. I don't know if there's anything on the QSPI flash, but we can try turning it on. I won't be flashing the SD card just yet, so that you have to subscribe and wait for the next video if you want to look at it. And so let's just quickly connect a micro USB port and see what's on the SPI flash, if there's anything on there, and if the if the board comes alive. So it shows 4 TTY device. I'm not sure which. I think it was the first one's always UART with the Xilinx parts. They always have 4 TTY devices, and Vertis and Vitis uses them. Vitis and Vivado use them to flash and live boot the PL and stuff like that. So let's do a picocom on this. Let's see if anything comes up. We'll try another one. But if there's nothing on the QSPI flash, it's not going to push anything. So don't be mad if there is. So it spun up and nothing on the UART. So alright, kind of what I expected. Even especially if. Oh, there you go. Wait, something's on the UART. I think it's just the U-boot. Okay, reset. Yeah, so that's the Xilinx first stage bootloader. So plus point to Xilinx on this, like they ship U-boot on the SPI flash. Woohoo! That's something I like to see more in the ARM ecosystem in general, and Xilinx is doing that. So yeah, I'm pretty happy. Ooh, it's pretty recent. Not too old. It's not 2016 or 2017 like I'm used to seeing, but it's 2020. A year old. It's fine. It's better than anything else. Right. So it powers on. I mean, as I said, if you want to see more, if you want to see the software side, if you want to see why this can be set up to run an AI example in 1 hour, make sure you're subscribed, and I'll catch you all in the next one where we'll see what's really going on the software side and why Xilinx is pushing this board so much. So thank you so much for watching. I hope you enjoyed this video and learned a bit more about this board from a hardware perspective. And what are peripherals on there, what you can do with it, and again, as I said, on the software side, I'll catch you all next time.